very much for having me. I appreciate everybody attending and being here on a Saturday. I hope that everybody is staying safe in this global pandemic. My name is John Morehouse, and today we're actually going to be talking about improving performance with intelligent query processing. We actually learned about some of these features that Microsoft has released in a previous session, and Kathy had mentioned that she actually could spend an hour, and in this case, I'm going to spend 50 minutes talking about intelligent query processing. So we've heard from a couple of different speakers about this feature, so that might tell you how important it is to take a look at this so that you can improve performance of your everyday workloads. I do work for Denny Cherry Associates, and my clicker is not working because it's Saturday and it just doesn't want to work. Oh, come on. There we go. Okay, cool. I work for Denny Cherry Associates. It's a small boutique of IT professionals. My contact information there is on the slide before you. Email, LinkedIn, Twitter, my blog. Feel free to reach out to me if you have questions about the presentation today, or even if you have questions about overall SQL Server performance or health. If you're stuck on something at work, feel free to drop me a line. Everybody at Denny Cherry Associates is pretty heavily involved in the community. We like to help if we can. If it takes more than a couple hours, then we got to talk about a contract. But I speak quite a bit throughout the years, even virtually as we are today. I am a MVP data platform with Microsoft, and it's a big honor to be a part of that program. I am also heavily involved in my local user group here in Louisville, Kentucky. I will say that it took me like 18 months to figure out how to say Louisville correctly when I moved here. So just a quick blurb about Denny Cherry Associates. Like as I said before, we are a small boutique of IT professionals. We love doing SQL Server stuff. If you're stuck and looking for a project, feel free to hit us up. With that, this is kind of what we're talking about today. We've as I mentioned, several speakers have already kind of touched on these topics, but we're going to go back down into it. We're actually going to do some demos, and we're going to look at some XML execution plans. But we're going to talk about lightweight query profiling, the table variable deferred compilation, ScalarUFD Inlining, row mode, memory grant feedback, batch mode on Rowstore, and I've got demos of all of that. So we can look at these features that Microsoft has released, especially starting with 2017 and whatnot, to help you improve performance of your workloads. And the important part is without changing any code. So this all started back in 2017 when Microsoft started to release some of these features, and they were known as adaptive query processing. When Microsoft released 2019, they rebranded that into intelligent query processing. So when you hear the term AQP, they're actually referring to those features that were released with SQL Server 2017. IQP is now the overall arching umbrella of those features that came out in 2017, in addition to the features that they released for SQL Server 2019. And Microsoft is pretty smart. We as data professionals have a challenge when it comes to performance tuning. We always hear about wanting to improve performance without making any code changes. So we can't change the application, we can't change certain facets of the environment, but how do we make things go faster without introducing, potentially breaking changes to the application, or again, we break something else in the environment. So Microsoft knew that was a challenge, and Microsoft stepped up and said, we got this. And so they started to introduce some features into the SQL Server product to help us facilitate that end goal of improving performance. And the first part of that is they had to introduce some lightweight query profiling. Lightweight query profiling allows the engine to get better metrics on your queries to make adjustments down the road, right? So this actually provides a framework, so we can use that framework to do better performance tuning automatically using some of these features. Now, with SQL Server 2019, it's already enabled by default. But if you're on a previous version, so 2017, you actually have to opt into this lightweight query profiling by using traceflag 7412. I highly suggest if you're going to turn that on, test it. Don't go to production and put this into production and say, hey, John said to do this, because that won't work. But you can turn on traceflag 7412 and opt in for this lightweight query profiling, and you can start to get some of these features for intelligent query processing. Now, and we've seen this a couple times already today. This is the overall arching umbrella of intelligent query performance. So we can see here on the left, and this is the graphic comes from Microsoft. I wish the colors were a little bit different. But here on the left that you see in the red blocks, those are the ones that were rebranded as from AQP to IQP when 2019 was released. So those, and we've already seen a couple of sessions about it. Kathy was talking about the batch mode, and we've seen the interleaved execution and the batch mode and the memory grant feedback. Microsoft took that and improved on it and then made it into the IQP, which now, again, is the overall arching umbrella of all those features. So if you're on 2019 or in Azure, if you're running an Azure SQL database, some of these are already in place in Azure. They don't all work with an Azure SQL database, and we'll talk about that down the road. But if you're already in Azure, you might already have these in place today. And so you can take advantage of these features pretty quickly right out of the gate. Now, one thing to note about IQP, as well as pretty much any feature for the most part moving forward, and Microsoft's pretty smart. So if you've been around, if you've been a data professional for a while, you'll remember back in the day when everything was certified on what version or edition that you were running of SQL Server. Well, starting with, I think 2016, SQL Server 2016, Microsoft started to move away from that type of validation to say, hey, we're now going to certify your application based off the compatibility level that your database is running in. So this gives better flexibility for database administrators or even data professionals that we can control what features are enabled for our applications by changing our compatibility level of the database. And so thankfully, if I happen to be running a higher version of SQL Server, I can lower my compatibility level to meet the needs of my application if I need to. Most likely, I always want to be at the highest level of compatibility so I can get the best features and the best performance, but it's not always true. So you might incur some sort of performance regression by moving to the highest compatibility level. The important part is to remember that this is all controlled by the compatibility level. So we can shift things just by flipping a switch with the individual database, okay? When the lightweight query profiling came out, we also got some new features and some new DMVs that proved to be pretty handy. At least I think they're handy from a data professional performance issue. So the first one we're going to talk about is actually available in 2016, SQL Server 2016, Service Pack 1 or higher. We actually get a DMV now that we can actually see a query in flight and get metrics on that query. So if we have a session ID and you are able to capture that query while it's in flight, if you have long-running queries, it's easier because they're still running. If you have a lot of smaller queries, it's a little bit harder to capture because as soon as the query is finished and executed, it gets removed from that DMV and we can't find it. But we can actually use that DMV to see those in-flight queries and get real-time execution plans and other metrics of that query. Now in 2019, they also introduced one that was 2019 or higher, is a query completion. So we can actually see, before you had to go interrogate the plan cache to go get the estimated plan of the query. Now the estimated plan and the actual plan in shape form should be the same, but the runtime metrics are going to be different with the actual query plan. With this new DMV, the query plan stats DMV, as the query gets completed, it actually saves the actual execution plan, not an estimate, but the actual execution plan that we can then go interrogate and extract and do analysis on if we need to. That's pretty handy these days. So we get the actual runtime metrics of that query plan. Now, we do have to enable a database scoped configuration, and it's last query plan stats. We have to make sure that that configuration is enabled in order for that to work. But that's part of that lightweight query profiling that Microsoft introduced to help us get better performance. So that's kind of the lightweight query profiling. And so right now we're going to jump into the table variables, and we're going to go look at the table variable deferred compilation. If you've ever used table variables in your code, you probably ran into this many times. And The issue with table variables as it stands today, with no other changes, is that SQL Server doesn't know how many rows you have in that table variable. You could have 5, you could have 100,000. It doesn't really know. And so we can see here from this example from a query plan, it thinks it has 1 row. And so the query plan is almost always horrible. And you get bad performance because it doesn't have a good idea of how many rows are really in that table variable. With the deferred table variable deferred compilation with 2019, we actually can now get a better estimate. So anything before 2019 was a 1 row fixed estimate. Too many rows was a bad execution plan. And using that, and before you always had an option between a table variable and a temp table. And my recommendation has always been, if you have anything more than 1,000 rows, throw it into a temporary table because the query optimizer can get better metrics on that data. You can put indexes on, you can adjust statistics. There's things you can do with a table, temporary table, to get a better execution plan than you could with a table variable because of that 1 row fixed estimate problem. With table variable deferred compilation, now the compilation is actually shifted to the first execution of the statement. And what that means is that SQL Server can now get a better estimate of the data that is contained within that table variable. So with this, we can enable this. And if we have table variables throughout our code, we actually can get better execution plans. And if we get better execution plans, then our queries run faster. If our queries run faster, we sell more widgets. If we sell more widgets, my bonus gets higher. It's all about me. And so this is really important to me, especially when I go in to do performance tuning, because this is an easy fix to, hey, you got a lot of table variables, throw on deferred compilation and watch things run. Now, it's important to note that the compilation frequency remains the same. So it doesn't change that compilation frequency. All it does is it allows that compilation to be deferred slightly so that we can get a better estimate of the data that's in the table. Now, this mimics more like a temporary table. So now we have a little bit slightly different problem of where do we use table variable versus a temporary table? And my answer to that is test it. Your workload might vary. You know, your mileage is going to vary depending on what your workload is doing. So I would say throw it into a test environment, test your production workloads in that test environment and see how it behaves. But now we have a better option with table variables to get better performance out of it long term. So that was table variable deferred compilation. I think it's a huge win for Microsoft to throw out there. I've seen table variables used in code on a weekly, daily basis when I look at clients. So it's a really huge win. The next one that I really like is ScalarUFD Inlining. And this is another one of those, very much like table variables. You know, there's a dangerous point in using a table variable in previous versions because it's always going to get that 1 row estimate. Scalar functions has always been a huge pain point with performance with SQL Server in the way that it executes that code. It always will execute it in serial versus a parallel mode in the execution plans, which means that if you had a result set coming back from SQL Server that was 100,000 rows, or let's up that. Let's say 1 million rows. It has to apply that scalar function in a serial format against every single row. And so it was always going to force a table scan or an index scan when you use that scalar function, and your performance was horrible. Code reuse is great, but if we can't change any of the application code, we have to be able to change something in SQL to improve performance. With ScalarUFD Inlining, we can now get a parallel execution plan and get better performance. So Scalar UDFs were not previously costed during compilation. And we got a couple of different ways to actually enable this. It is a database scoped configuration, so we can adjust it there, but we can also adjust it, and that first one is how we do it from a database scoped configuration. So we can turn it on and off there. We can also use a hint, so we can disable that scalar functioning if we want to using a hint, or we actually can have a inline command to turn it on or off. And we can also, again, the database scope configuration. Now, with some things that Microsoft releases to help us be better data stewards and improve performance, sometimes there's always gotchas. And the Scalar UDF inlining is one of those that comes with a bunch of gotchas. And this is one that is not available for Azure SQL Database. It is not there yet. I expect it to be there. I have no knowledge of that whatsoever. But I would think that Microsoft will eventually get that into Azure SQL Database. But we have a whole slew of requirements before SQL Server will actually inline that function to give us better performance. So there are limitations, and those limitations are kind of long, as you can see as the list moves on. If your Scalar function falls into any of those requirements, then SQL Server is not going to inline that function, and you won't get the performance benefit from that capability. Now, if your function does not fall into that list and can be inlined, we can actually see when that function gets inline or is inlineable with the sys.sql_modules system view. So we can actually look at that function and see if that function can be inlined or not to help us facilitate better performance. So if you happen to be in 2019 and have it enabled, go take a look and see if that function or those functions are inlineable. You might be seeing a vast improvement in SQL Server performance because SQL Server can now inline that function and get a parallel execution plan and not stick with a serial and not get a table scan. All right. So we talked about table variable deferred compilation. We've talked about scalar functions inline. I've got demos of all this. So when we get to the demo piece, the next one we're gonna touch on really quick, and I feel like I'm moving really fast, is memory grant feedback. This is another one that I really like that SQL Server has put into place to help us get better performance and better metrics. It was added in SQL Server 2017, but it was only added for batch mode. And in 2017, batch mode was really only for column store indexes. So, but it doesn't actually change the execution, but it changes the context of the query. So if you've been doing performance tuning, you've probably at some point in time seen things that are like tempDB spills. And so what that really means is that if there's not enough memory granted to the operator of that query, particular operators in the query, the operator can say, hey, I don't have enough memory, so I'm actually going to go use tempDB to facilitate that. And that's a spill. That means that the query has actually spilled over to tempDB to facilitate processing the data within tempDB in order to satisfy the query requirements. Memory grant feedback allows the engine to adjust things based off what happens. So if we get a spill to tempDB, and the query needs more memory, the memory grant feedback on subsequent executions can actually allow the engine to say, hey, the first time we ran this, we spilled the tempDB. I didn't have enough memory. I only got 10 megs of memory, but I needed a gig. The engine can now adjust on subsequent executions and say, hey, first times you didn't have enough memory. This time, we're actually going to give you more memory based off what the metric said from the previous execution. So SQL Server can actually adjust the memory grant for the query and the operators to facilitate better execution so that it doesn't spill to tempDB. If a query spills to tempDB, you can get performance issues. So this is one way that the intelligent query processing with the memory grant feedback, we can get better performance because the query can actually adjust as needed. So I can give it more memory, but it can also decrease the memory, because if I give a query or an operator too much memory, then I'm potentially starving memory for other queries. Other queries might need more memory because of the way that the query is running, where the operators it's using. So the memory grant feedback can actually dynamically adjust each query based off its true needs. Because we have that information, those metrics from the lightweight query profiling that SQL Server now uses, we can actually adjust that memory up and down depending on what we're actually doing. So this is a really cool way that we can dynamically adjust the performance and not spill to tempDB and or starve other queries just by enabling the memory grant feedback with the database scoped configuration in our code. Again, these are things that we can turn on and off without changing a single lick of application code, which shouldn't break a thing. Test everything, always test, but we should be able to turn this stuff on pretty easily. So that was memory grant feedback. All right, so the next one I really like is batch mode on Rowstore. So when column store indexes came out and whatnot, they actually introduced a new way to process data out of those column store indexes, and it was in a batch mode. But if you don't have column store indexes, doing a batch mode is actually better performance because it would process rows at about 900 rows at a time. It really was introduced with SQL Server 2012 and column store indexes, as I mentioned. But because we can process rows at about 900 at a time, SQL Server can process larger sets of data better. It is great for analytical queries, and that's one of the benefits of using column store indexes if you have a large data set. But what if I have a large data set that's not analytical, it's online transactional processing, but I still want to take advantage of that batch mode? I can't do it unless I get to SQL 2019 and enable this database scope configuration, this batch mode on Rowstore. So that batch mode also reduces CPU consumption. So not only do I get better performance, I get lower CPU. So again, it's great for analytical queries, but I can't have one or the other. So I'm either going to be in a batch mode or a row mode, but I can't be both. But with batch mode on Rowstore, now that I have that online transactional processing workload, maybe I've got 100 million rows in an OLTP table, turning this on, I can now get better performance with a batch mode on a Rowstore and not a batch mode like on a column store index. So I can enable this, but there can only be one. So it's one or the other. So these are 4 of the intelligent query processing things that I think are a really great addition to SQL Server, especially SQL Server 2019. So now we're going to jump into demos. I feel like I'm moving really fast. I've got about 20 minutes left, 25 minutes left. Are there any questions, Simon, before I jump into the demo?
We're good.
I'm going to shift things around while
You can take your time. It's okay. You got to breathe now. You can take your time.
Let me see. Can I switch my screen?
Yeah, you can. There are no questions. It's okay.
Let's see. How do I switch my screen? There we go. Okay. Yep. Hang on. Ta-da.
Okay, I did back.
Perfect. Yay. All right. Hopefully everybody can see that. This is my management studio. And I apologize. I feel like I am flying right along. So this is the first one we're going to look at, and we can see that I am, this is a local SQL Server 2019 instance on my work laptop. It is running SQL Server 2019. Don't mind the whole slew of databases I have. I tend to really try to break my local instance quite a bit. But these are just examples of, if I use AdventureWorks 2017, we can actually see that lightweight query profiling is a database scope configuration. I do have last query plan stats enabled here, so I could see it. Now, I don't have any active workloads on this particular database, so I don't see anything in this DMV at this point in time. I can go back though, because remember with the lightweight query profiling, we also got the ability to see the query plan stats, so I can actually go back and see the actual query plans, not the estimate, but the actual query plans that were landed after the query finished. Now, these are all system ones. Maybe if I went down through here, I could find something that was more application-based. Let's see. Looks like these are all system ones, no big deal. Just an example that I can actually go get the actual query plan, not the estimate. So that's just an example of lightweight query profiling in some of the cool DMVs you get right out of the box. So let's take a look at the first thing that we talked about, which is the table variable deferred compilation. In this case, I'm actually going to use, and I always say it backwards because I want to say worldwide importers, but it's wide world importers. But we're going to use the wide world importers sample database in order to mess around with some of this stuff. I'm going to check to see what's enabled. We can see that I've got the deferred compilation table variable enabled. I do not have the last query plan stats enabled. In this case, I'm okay with that. But I do have the lightweight query profiling. I need that lightweight query profiling enabled to take advantage of the features that I already previously talked about in the slides. So I'm going to go ahead and turn on the last query. Oh, I'm going to turn that on. And I'm also going to set my compatibility level back down to 2014. 130 is 2014, 140 is 2016, 150 is 2019. So remember that these features can be turned on and off based off what compatibility level you have your database set to. So I'm going to create a procedure in the database. It's going to do some work. And again, it's going to use a table variable to facilitate that. Make sure that's in there. Cool. I'm going to pull some data into cache just because. And then I'm going to run that store procedure that is going to use that table variable. And remember that I'm in 2014 compatibility, so the query optimizer thinks it's on for all intents and purposes, it's on a 2014 box and it's going to behave like that. And I'm going to run that. Now, if I look at the execution plan, we can see here that I have the table variable. But if we look, we can see here that as we expected, because I'm in the 2014 compatibility, I'm getting SQL Server only thinks that there's one row, but in reality, there's 228,000. That's a pretty vast difference in terms of how many rows are actually physically within that table variable. I want better performance. And so if I go back to my query and alter the compatibility level and bump it up to 150, which is 2019. And remember, I've got the table variable deferred compilation database scope configuration enabled, and rerun this. I get the same number. I'm going to look at the execution plan. We can see if we hover over my table variable now, move over here, I now have an estimate of 228,000 rows, and it matches my my actual rows that it read out of that table variable. This allows the query optimizer to get a better execution plan. You'll also notice that the execution plan shape actually changed based off using that table variable deferred compilation setting. So I actually get a physically different execution plan. So really, as you can see here, really easy to enable, doesn't take much, but we can see a vast difference in terms of execution plans. And you can see where the performance would be better by turning on the table variable deferred compilation. We'll clean some of these up. So the next one we talked about was the inline scalar function. So let's go ahead and take a look at this. We're going to use, again, the wide world importers. I'm going to set the database back down to 2017 compatibility level. I'm going to use the database. And whoops, let's say don't type in a demo. So here we can see that the database, now everything's turned on. In the previous demo, I turned on the last query plan stats. This one already has the Scalar UDF inlining turned on, and I've got the lightweight query profiling enabled as well. Here, I'm going to create a function in the database, if it's not already there, that's going to basically just count some quantities out of the sales order lines table to do our function. Now, so I've got this noted, and I keep grabbing the wrong thing. I have this noted that it's going to take 3.5 minutes to run. Looks like we have about 3.5 minutes, but I'm not going to let it run. But if I start this, we can see that we get results back. And actually, I need to turn on my actual execution plan. And that's actually not going to finish. So we're going to do this. We're actually going to use that new DMV in order, because this query is in flight, I can actually come over to a new session. See if I can find it. So this is the actual execution plan of the query that is currently in flight. So I can actually see what this is doing. Now we can see this plan looks pretty simple, pretty straightforward. It's not overly complex, but we can see that it hasn't actually expanded that function to be inline. And so we can see that we're going to get a clustered index scan out of this query. So if I come back over to my demo and cancel that, we're going to cancel that. So I'm going to go ahead and up this to 150. So again, I'm going to put it back into SQL Server 2019 compatibility and run it again. Can I move that? Oh, cool. I can move that. Now we can see that the query actually completed. So it's not running anymore. So I can't grab it out of that in-flight DMV. Now I can actually get the execution plan. Now in this case, I had enabled to show me the actual execution plan, but I could go get it from my new DMV if I wanted to. Well, notice that the plan shape has really changed. We can actually see now that we actually get it expanded out, and it actually puts that function in line with your code. So we get a better and a different plan shape out of SQL Server. So this will perform better if you are using scalar functions. This is one of those features with SQL Server that really helps us improve application performance, because we all like to do code reuse. And so having code reuse in a scalar function, we now have a way to improve that performance with the newer versions of SQL Server without making a single change to an application somewhere. So this is one of those ones that I really like from a DBA perspective, because battling scalar functions was always one of my worst nemesis, because there's not much you can do other than completely rewriting that function and injecting it manually into your code in terms of stored procedures or SQL queries in order to get things resolved. This makes my life easier as a data professional and doing performance tuning. This definitely makes my life easier in terms of getting better performance by a simple switch of the button. So I really like this one. Okay, so that was scalar function inlining. So pretty easy to enable, pretty easy to see where this could be applicable in your workloads. And so let's go on to memory grant feedback. This is another one that I really like. And again, I got about 15 minutes left. Again, I feel like I'm just screaming along. So let's see. We're going to use wide world importers still. I'm going to go ahead and clear the cache out of the database scope configuration. I'm going to set the compatibility back down to SQL Server 2016. So I hope you see how the database compatibility level really helps to adjust what you can or cannot do with your databases moving forward. So if we look at the available database scope configurations, you'll see that there are two. One is batch mode and one is row mode. Remember that the batch mode really pertains to like the column store indexes. So that's been there for at least 2017. So the row mode is the new one that we really like. So if we do a query on wide world importers, I don't have my query plan enabled. Of course not. Oh, I do. I thought I didn't. So we're going to run. This should not take long, I don't believe. It comes back. So in the lower compatibility levels, and we've probably all seen this warning, we can see that yellow bang warning that a SQL Server is telling you, hey, there's a problem with this query. You might want to take a look at it. And so if we hover over that, one of the things that we'll notice is down here in the bottom, SQL Server is telling us, and remember, I'm in the 2016 compatibility. SQL Server is telling us, hey, I gave you way too much memory for this particular query. I initially gave you 731 megs, but you only used 5.4 megs of that 731. That's a pretty vast difference in terms of memory utilization. And think about, now this is my laptop, right? I don't have any other workloads going. If you have a very busy system, that excess, 726 megs could be very much utilized in a different query elsewhere and not starving a query somewhere else in the system. Okay, so if we change the compatibility level up to SQL Server 2019 150, and we talk about, and then go look at the execution plan again. Oh, whoops, the other thing I wanted to show, actually, let's go back here. Actually, we'll just move on. I did not show what I wanted to, but we'll come back here. So I've bumped it up to 150, so I'm in 2019. I've got that memory grant feedback enabled. We look at the execution plan. We still see this. We still see this memory grant and the warning down here. We can see that the memory grant changed slightly. I'm still using only 5.4 megs, but they gave me 819. Thankfully, I've got 32 gigs of memory on this machine. But if we look at the execution plan XML and come in here, one thing I want you to look at is this memory grant info line right here. So we will look if, and in the previous XML, this wouldn't be here. But what I want you to look at is this feature, is memory grant feedback adjusted? So SQL Server knows that that memory grant feedback option is enabled and is telling us in the XML, hey, you've got it enabled, but you have to run the query first to level set that expectation in terms of what memory I am using. So it's the XML from the query plan is actually telling us, no, it's the first time you've executed this since enabling this feature, so I need to do metrics first. I'm not going to adjust a thing until subsequent runs of this particular query. So if I come back to the query, I'll back out of this and run this again and let it finish. Couple things here. We'll notice that I don't have a warning anymore. There's no yellow warning sign on this select operator right now. So if I come and look at the execution plan XML, let's go take a look. So again, I'm going to look at this memory grant info line in the XML. The XML will actually tell you a ton of information. If you haven't looked at the query plan XML, there's a ton of information in there. We look at that is memory grant feedback adjusted line. SQL Server then said, hey, I gave you way too much memory that first time. I'm going to adjust my memory grant for your query, and I'm going to dynamically adjust it down and only give you what you need. So we can actually come back out and look at the execution plan. Where'd it go? I gotta go find it right here. I can't see, the memory grant is much less. If we actually look at the mouse over, we can see that instead of 730 megs or 800 megs of memory, SQL Server actually says, hey, you only need 5.5. I'm going to give you 8.5 megs of memory just to be safe. But 8.5 is significantly less than the 800 megs of memory it gave me the first time after turning on this feature. So I get better performance. I don't spill to temp DB with this. And I'm not starving other queries elsewhere on the system by having this enabled. And again, think about it from a global perspective. If I have an application that is has queries that are doing excessive memory grants and lots of spills to temp DB, this is an easy fix to get better performance right out of the gate with a couple simple changes. Again, test everything. Your mileage may vary, but test everything. You can see where performance can definitely improve. Okay, I got about 9 minutes left. So the last one, batch mode. And again, the batch mode on Rowstore allows us to process, especially online transactional processing data, kind of like it's analytical. In this case, I'm actually going to switch over and I'm going to use AdventureWorks data warehousing and use that database instead of wide world importers. I am going to set it down to 2016, SQL Server 2016. I'm going to check to see if I have batch mode on Rowstore enabled. I do, so it is enabled, so I can utilize this feature to get better performance. I'm going to take a look at a query, and this query is actually going to touch a column store index. So we can actually see here if we hover over. So this is my fact reseller sales XL column store, clustered column store index. If we hover over it, we can actually see that my execution mode is batch mode. So this means that I am processing rows, about 900 rows at a time, give or take. It's approximate, but I'm executing that in a batch mode process, and I want to apply that batch mode into a Rowstore. So it's pretty easy to enable. And I know Tracy's coming up behind me, so I want to get this done. I think I missed a 150. Oh, whoops, I did. That's what I was doing. Set that back to 140. If I execute that, just real quick, I want to try to get out of Tracy's way. Let's see if this comes back. If I look at the execution plan on this Rowstore, we can see that I'm actually in a row mode, right? I'm not in a batch mode. If I enable 150, I'll just run this one to speed things up. So I'm going to run this. This is against a Rowstore table. I don't have a column store index on it, but I can look at the query plan. We can see that my plan shape's a little bit different. If I hover over it, we see that we actually get a batch execution mode. So now we're using the batch mode on a Rowstore. And so we get better performance because we're processing data in a faster set, just like we would with a column store index. So we get better performance long-term by a simple change. So those are my demos. Let's see if I can. And that's not going to work. Oh, my screens are all jacked. Sweet. Let's see if I can do this. Tracy, I'm so sorry. That's still not going to work. Well, so I will just talk through it. We can just do this because my screens just don't want to work right now. So there's with these new features with intelligent query processing, some of them are not enabled for all versions of SQL Server. So the batch mode on Rowstore and the row mode memory grant feedback is only available for enterprise. The other two you get with standard. So if you're running standard mode, you can take advantage of those. If you're running enterprise, you can use all of them. And again, the inline ScalarUFD Inlining isn't available for Azure SQL Database at this moment. Again, I expect somewhere down the road it'll come to play. Quick summary. This is a really easy way to get performance gains out of your SQL Server environment. You get better flexibility, and just remember that you have to be at compatibility level 150 in order to take advantage of it. So definitely test your applications with the higher compatibility levels, but easy way to get better performance, pretty straight out of the box and easy. So, and it's a great way to get rid of anti-patterns. If you've got bad code, turn some of this stuff on, you can get rid of anti-patterns. And with that, I'm done. Thank you very much.